We are okay. So, before we start, tell me, is this factored or expanded form? It is factored because you have something times something. So these are factors. Yes? If you have factors, then you will expand. So let's expand that. You should be able to do it in 1 second because that's a shortcut one, yeah?
But the shortcut doesn't work for...
No, it doesn't. X squared plus how many x's? 10 x's plus 24. Yeah? Alright. What do we call that mathematical expression? Starts with a P. It's a polynomial. What special type of polynomial? A trinomial. Excellent. And this trinomial is in what we call general form. General form, which I described to you a couple of days ago, is this. ax squared plus bx plus c. That is general form. Okay? Now you will notice general form has a quadratic term, x squared, a linear term, 10x, bx, a constant term, 24, and c. Cool? Alright. Now you will notice that in general form, a is the coefficient that is with x, yeah? What is a over here? 1. And you guys already know how to factor this, right? You find the numbers that multiply to 24 and add to 10. Everybody knows how to do that already, yeah? Now, sometimes you're faced with something that looks like this. 2x squared plus 20x plus 48. And you don't know how to factor that yet because it's got a leading coefficient. But you do know how to factor it when it doesn't. So this one, all we would do is we would divide the 2 out, wouldn't we? And we would get x plus 10 plus 24. Everyone cool? Everybody good?
Can you multiply it then divide it?
So what do you mean by that?
Like multiply 48 by 2 and then...
Yeah, we're getting to that. Stop giving us away. That's what we're going to do today. But you wouldn't do that because you always GCF first. So, guys, before we go any further, if I asked you to factor that right now, it looks like you can't do it, right? Because it's got a leading coefficient. And we only know how to do it when a is 1, correct? So right now I have given you one thing that will fix this up for you. That's Gcf factoring, right? So we want this to have a 1 there. So that would mean I would have to divide by 3, correct? Does 3 work with all the terms? Yes, it does. So then I would take my GCF, 3, and I would write all of these quotients. X squared plus 7x plus 12. And now this is something we can factor, isn't it? Because it's got a leading coefficient of 1. This I need to multiply to 12 and add to 7, which we just did in our warm-up. What is it? Yeah, x plus 3, x plus 4. Is everyone cool? Okay. That's background. Now let's get to today. Factored or expanded? What is that? Are those factors or are they expanded? These are the factors. So when we see factors, what should we do? FOIL. Expand them. Distribute them. Whichever word you like. So let's do that. What is 2x times 3x? 6x squared. What is 2x times negative 2? Negative 4x. What is 1 times 3? Positive 3x. And what is 1 times negative 2? Negative 2. And then we put this into a trinomial, which is, of course, 6x squared minus x minus 2. Is everybody okay with that? Expansion. Now, we already know that when I factor this, this is the answer, correct? But let's pretend that we don't. So now I have a trinomial that I wish to factor. So you say to yourself, okay, I know how to factor trinomials. I don't like that 6 because I only know how to do it when it's a 1. Okay, but Mr. Myers says that we can get rid of that 6 if we divide by 6, right? Well, let's check. That guy divides by 6. Does he? No. Does he? No. So I can't GCF this one. So now I gotta do a new thing, and I'm about to teach you how to do it. Now listen to me. There are 3 ways to do this. One is very difficult because it takes a lot of steps, but it's easy to see why it works. The second one is real easy to do, but you got to memorize a bunch of steps. They're like instructions. The third way is the way that Felix and Peter probably learned, that requires some guessing and it requires you to be really, really good at multiplying. Okay? I am going to show you the way that is the easiest to do because it is almost exactly the same as the factoring you already know. That's the one we're going to put in our notes. Then I'm going to show you the other 2. I'm not going to make you write them down. I'm just going to show them to you so you're aware of them. And if you like them, you can do some more research and decide to use one of those methods if you like. Is everyone okay with that? All right. So, this is what we want to factor, yeah? So here's how we do it. I've got it right here. Now, you guys are smart kids. You know that when you factor this, you're going to end up with 2 binomials, aren't you? And you know that those 2 binomials have to multiply together, don't you? Right? We just did it. 2 times 3, right? We did FOIL. So we know that's multiplying, yeah? Everyone cool? Okay. You also know how to factor if there's nothing in front here, don't you? Everyone cool? Okay. Now, observe. How much bigger is 6 than 1?
6 times.
6 times bigger, yeah? Which means everything in here, if I were to factor out that 6, would have to be divided by 6, wouldn't it? Everybody with me? So what we do when we are faced with this, step 1, is we do A times C. So in this case, what is A?
The coefficient.
The coefficient in front of x. So what is it? 6. And what is C?
2.
Okay.
Negative 2.
-2. And that gets me negative 12, yeah? Now we do regular factoring. But instead of 2, we're using negative 12. So I have this, and now I need to multiply to negative 12 and add to what number? Negative 1. Is everyone cool? Okay. What are the factors of 12 that will get me to negative 1? Is it 1 and 12? No. Is it 2 and 6? No. Is it 3 and 4? Yes. Okay. So remember, I said we're doing regular factoring, right? So if we were factoring this normally, it would be x. This is negative, so it would be plus.
4.
No, positive 3, and x minus 4. Yes? Does everybody see why?
Yeah.
Okay, I want you to write this with a big space after the second one. Does everybody agree? 3 minus 4 gets me my 1, and 3 times negative 4 gets me my negative 12. Is everybody cool? Okay, now, our job here is to factor, yes? Right? Everyone agrees? Okay. And factoring is the reverse of expansion, right? What math is expansion? Multiplying. What math is factoring? Dividing. Have we done any dividing? No. Now we have to divide. What number do you think we must divide by?
6.
Why 6?
Because you multiplied, so it's just kind of...
Because we multiplied by 6 to get the 12.
6 and the 4.
So don't go ahead yet. We multiplied by 6 to get the 12, right? So now we got to divide by 6 because we haven't done any factoring yet, correct? Now, what do you think we're dividing by 6? The x or the 3 and the 4? What makes sense? The 3 and the 4, because it was the 3 and the 4 that got me 12, wasn't it? So I have to divide these guys by 6.
Oh no.
Now notice I've left a space here. Why?
Because you can't have a fraction.
I can't have a fraction in there. And would I ever write a fraction in the 10th grade of 3/6? What is that? 1/2. Would I ever write 2/4? No, what is it? 2/3. Okay? Now I'm going to do something that I never, ever do in math class. I'm going to tell you to do something, and I'm not going to tell you why. Okay? Everybody cool?
Do you know why?
I know why. When you get to the smallest fraction you can have, you take the denominator and you move it to the front. Then you take the denominator and you move it to the front. So this becomes 2x plus 1 and 3x minus 2, which is what we knew the factors to be. Is everybody okay? Now listen to me. Bryce, just hold your question for 1 sec. Please be aware that this unit is extremely mechanical, isn't it? If it looks like this, you do this. If it looks like this, you do this. If it looks like this, you do this. Right? So the best way to get good at this is practice and repeating. So we're going to do a ton of it. All right? Bryce, question.
So it might just be because it worked specifically for this question, but couldn't you have just found two numbers that times in 6, which would have been 2 and 3, and then done it normally? Because that specifically would have worked for this.
Yes. And I'm going to show, that's one of the extra things I'm going to show you. Okay? Everybody cool? All right, now I'm going to very quickly show you the way I was taught to do this 25 years ago when I was your age. And I'm going to show you the way that I bet Felix and Peter were taught. But I'm not 100% sure. Okay, so first thing we're going to do what I did. 6x squared minus x minus 2. So here's what I was taught. Step 1, same step. Minus 12. I got to multiply to minus 12, add to negative 1. So it's 3 and 4, right? So then we were taught to rewrite it. 6x squared minus 3x, minus 4x, you put the smaller one first, plus 3x minus 2. See how it's the same thing? I still got my x squared, negative 4 plus 3 is negative 1, right? And there's my negative 2. Then we were taught to make two groups. Okay? Then we factor this. This can give me a 2x, yes? So that's 2x is going to come out, and that's going to leave me with 3x minus 2, correct? Right? Now, does this side have a common factor? It's the factor that's common to everything, which is 1, correct? So I divide this guy by 1, I put a 1 out front, and I have 3x minus 2. Now notice, this and this are the same factor, aren't they? So they can come out, 3x minus 2, and what was left? 2x plus 1. This is how I was taught, and apparently how Bryce and Bradley were taught. That is called decomposition. I don't like it, and I just spelt it wrong, decomposition. Decomposition. I don't like that. I was taught that. I used to teach it that way to kids. Kids didn't get it. So I went on the internet and I found another way to do it, which is the way I just showed you in your notes. I find that way easier. But remember, you don't know why it works. This makes sense all the way down. If you like it, use it. Now, as Bryce said, he looks at this and he says, well, couldn't you just, you know that it's got to be 2 and 3.
Yes, that would work all the time.
It does, but I'll show you why it's a problem. Okay? So this, I'm betting, and I'm not totally sure, but it was a kid from China that showed this to me. This is another way to do it. 2, 3, and then this has 2 has factors of 1 and 2, correct? Now, these both have to be positive, because I need positive 6, yeah? One of these has to be negative, doesn't it? Right? So you guess. I'm going to say the 1 is negative. Okay? Then you crisscross. What's 2 times 2? 4. What's 3 times negative 1? Negative 3. Is 4 minus 3 negative 1? 4 minus 3? No, so this is wrong, right? So now we try again. 2/3. Now it can't be a negative 1, so it must be negative 2. Now let's crisscross. What's 2 times negative 2? Negative 4. And what's 3 times 1? 3. Does that get what we want? So this square is correct. And then how do you get your factors? You go straight across. 2x plus 1, because that's 2x. These are the x's, these are the constants. And then this is 3x minus 2. Is that the way you guys were taught? Yeah. That's why I don't like this, because it requires guess and check. Now, eventually you get so good at factoring, you can do this, right? Again, well, that's what I mean. That's why I want you guys to have the choice. Okay? I like the one I showed you in your notes because it mirrors the one you've already done, whereas this is totally alien. Right? Now, this will work with a regular one. When this is 1, you can still do this square thing. It's up to you. I'm not a big fan of it. Because at the beginning, you're guessing too much. Because this could also have been 6 and 1, right? And you could have had 3 on top instead of 2. If you did 3 and 2, it would have been screwed up, yeah? You got to practice a bunch to make this one work until you get good at it. When you get good at factoring, this is really elegant, right? But this way works all the time, even though it's not as pretty. Okay? All right. Now, we're going to skip number 1 because the numbers are big. We're going to go straight to this one. Okay? Now, I'm going to do most of these in the way I did in the notes. I'll do a couple with, I'm betting that most of you did not like decomposition. But some of you might like this. So I'll do a couple with the square method, which is called box factoring. But I'm going to do most of them with my method that I stole from an Australian math teacher. I hate it that he was Australian, but what are you going to do?
Why?
Because Australian people just have this thing about them where they think they're better than everyone in the world. Exactly. You believe them.
They're just so cool.
No, they're not. They have an accent. That's the difference. Right?
How's the Australian rugby team?
Yeah, exactly. They're no different than a Canadian rugby team, except they're like, "G'day, mate. Hey, Sheila, how's it going? Let's have a beer. It'll be bonza." Huh? Now, don't take that to mean I don't like Australians. I just don't think their egos need any more boosting. They're already from a beautiful country. But everybody talks about how beautiful and awesome Australia is, but it's really only beautiful and awesome around the coast. The entire middle is a desert wasteland that nobody talks about. The entire middle. It's almost the size of Canada. And it's all desert and dirt and rock. I know, because that's how mad I am that everybody from Australia thinks they're the heroes of the universe. Now, that being said, I know plenty of Australians that I just love. But
it's true. When you're from a different country, you always like...
I know.
I'm always like, I'm Spanish. I'm Spanish.
If I went to England, which I have done, and I order food with my Canadian accent, people are automatically more interested in me.
Unless you're American.
Now, that being said, I'm a pretty interesting guy. And when I walk up to a bunch of English people and say, "Hey guys, let's have a beer," they want to have a beer.
What the drinking limit is in England? Freaking ridiculous.
What?
The drinking limit.
Yes, it is.
It's like a pint or something.
Yeah. What were you going to say? Yeah, you.
What do you mean by Canadian?
How we all sound.
Okay, I thought you were doing...
No, Canadians have an accent. You guys will all say, "No, we don't." But ask anybody who speaks a different language.
Oh yeah, you do.
Of course we do.
Oh yeah, you do.
We don't say this word. No. No, you are saying water. That's a T. It's water. But we don't say it. We water. How do we say this word? You say battery with 2 D's. That's a T. It's battery. Canadians don't speak very clearly. Our accent is very mush-mouthed, which is why we have trouble with many other languages. That's why a French speaker from Quebec, everybody knows, you're not from France. You speak Quebec French. Oh, what do you mean? It's the same thing with Spanish. She is from Mexico.
No, I'm not.
Of course you are. Everybody in North America who speaks Spanish is Mexican. She's actually from El Salvador.
Well, I was born in Canada.
Yeah, but your family is El Salvador.
And
El Salvador, because they don't say V's. Yeah, so you got nothing there.
And the way Mexican...
The way she speaks Spanish sounds totally different to a Mexican, which sounds totally different to a Spaniard, which sounds totally different to a Chilean, which sounds totally different to a Colombian. And they could all get in a room and sit down and say, "Buenos dias" to each other, And everyone in the room would say, you're El Salvadoran, you're Mexican, you're Colombian, you're Spanish, you're Chilean.
One of them speaks it with a list.
Spanish.
Spanish. They're the list first. Barcelona. Buenos dias. I'm from Barcelona. Donde está la baño?
Buenas tardes.
Buenas tardes.
First
Right?
time I heard that,
Now Mexicans get all angry at that, but let's remember, the language is called Spanish. It started in Spain. But if you want to speak perfect Spanish, the argument is often that it is the South American Spanishes.
Yes. Yes, it is.
are you Argentina?
Chile and Argentina are argued to have the perfect Spanish accent because there's no local dialect that's crept into it. All this is for another day. Now, meanwhile, Peter and Felix over there, yeah, you Canadians can't speak to save your life. We have accents, don't we, Peter? All right, so let's do this first one. Again, we're going to do this the normal way, the way I showed you. So what's your first step? We multiply there. So I have to multiply to what? Negative 30 and add to what?
13.
Negative 13.
So you have to have a positive and a negative in your...
Yeah, so it's got to be S plus and S minus, right? Because this one's negative. What is it? Is it 1 and 30? No. Is it 2 and 15?
Yes.
Yes.
I do.
Plus 2 minus 15 will get me negative 13, won't it? Now what do I got to divide? The 3. Does that simplify? No. So where does the denominator go? To the front. 3s plus 2. Does that simplify? What is it? 5. So there's no denominator, so we write s minus 5. And then we check. Is 3s times s squared? Yeah, sure, you betcha. Is 2 times negative 5 negative 10? Yeah, sure, you betcha. So if the ends work, the middle works. It's automatic. Everybody cool? Everybody good? Okay. Look at this one. Now, I'm going to give you a hint. Look at it twice before you tell me what you're going to do. Simplify first. What do you mean, Bryce? I can divide everything there by 3. Because we remember what's the first thing we always try? Gcf, to make it smaller. So 3, 2x squared minus 7x plus 3. Now we factor this. So the 2 times 3, I got to multiply to what? 6, and I got to add to what? Negative 7. What is it? Minus 1, minus 6. Yeah? Agreed? What do I got to divide by now? 2. Does that simplify? No. So it's 3, 2x minus 1. Does that simplify?
Yes.
To what? To 3. X minus 3. Everybody cool? Everybody cool? Trust me, guys, this does take a bit of practice. Okay? We're going to practice once more here. Okay? And then I'm going to do the box factoring for you, all right? Just in case some of you like that better. So look at this. I'm going to change color to blue. What do I do with the 8? Multiplies by 5. So I need to multiply to what? Negative 40 and add to what? Negative 18. P, this is negative, so it's plus and minus, correct? So what is the factors of 4 that will get me to 18? What? 20 and 2. Which one's positive? 2. Because 2 minus 20 gets me 18. What do I have to divide these both by? 8. Does that simplify?
1 over 4.
To 1/4. Does that simplify?
Or 5 over 2.
5 over 2. Where do the denominators go? They go in front. Everybody cool? Okay. Now, I'm going to remind you with number 5 to double check. Can I make that smaller? Yes, I can. What divides into all of that? 4. So can I rewrite this as 4 6h squared minus 5h minus 4? Minus 6.
I don't really understand how to get out of the bracket.
We divided everything by 4. Now, if I distribute that back in, we get this, don't we?
Yeah.
So that's how it gets out of the bracket. We divided it out. Are you really okay? Mm-hmm. Okay. Now, this is what we would factor now, correct? If you wish, continue factoring this the way we've already done it. If you would like to see the box factor method, I'm going to do that over here. Okay? Everybody cool? So I say to myself, all right, because I've practiced this a lot, I'm going to say, all right, well, that's got to be 2 and 3. Right? That's got to be negative 6. So I'm going to go ahead and write negative 2 and 3. Right? Because I need a positive 6 and a negative 6, right? And then I check. 2 times 3, 6. 3 times 2, negative 6. Uh-oh, they're going to disappear. Can't do that one, can it? So I start again. I'll change this to negative 3 and 2. 2 times negative 3 is negative 6. Well, that doesn't work either. Damn it. So now I'll change the order. 3 and 2. 2 times 2, 4. 3 times 3, 9. Oh, crap, that doesn't work either. Because I didn't put a negative in. Negative. 2 times 2, 4. 3 times 3, negative 9. Does that get me my negative 5? Yes. So this is 4 bracket. We go straight across. 2x minus 3 and 3x plus 2. Everybody cool? Well, not x, h. Okay, now again, do I care what method you use? Not even a little. If you tried to do this the regular way, you should have gotten the same answer, though. Does order matter? Am I allowed to write this?
Yes.
Yes, because 5 times 2 is the same as 2 times 5. Am I allowed to switch the plus 2 and the minus 3? No. Everybody cool? All right. So you guys try number 6 with your method. What you like. The box or the method I showed you. I don't care. You guys try it. I'm going to let you get started on it a bit. When you're stuck, just stop. Don't stress. I will start working on it. When I get caught up to where you are, start writing. Okay? Go. Try that one on your own. Just keep running the steps. if you feel comfortable, we're going to go through this whole page up to number 19 is going to be part of your assignment tonight. Okay? There's some on the next page you're not going to know how to do. I'm going to do them as notes in a minute. Okay? So if you finish 6, just continue on. Okay? So I got to multiply to 12 and add to 13. So what is it? N plus 12, n plus 1, divide by 2, divide by 2, simplifies to 6, n plus 6, doesn't simplify, so the denominator moves to the front. And then I check. N times 2n, 2n squared, 6 times 1, 6, I'm good to go. Can everybody do it? At least a little bit. Can you stumble your way through, especially if you're working with someone beside you? Are we all at that point, at least? Yeah? Okay. I'm going to skip a few until 9. Turn your page over. I'm going to circle all the special ones that we're going to work through right now. These are the ones that we're going to work through, okay? Together. What makes 9 different from what we've done? It's got 2 exponents, okay? Do you think anything else changes? If this was 2 and 1, then we would do 9 times 4 and we would do everything normal, wouldn't we? Well, let's see what happens. 9 times 4, we got to multiply to 36, yes? And add to what? 12. Right? What is it? Pardon? 6 and 6. Everyone agree? Everyone cool? Okay. Now look. If this was t squared, then we'd go t and t, wouldn't we? Because t times t would get me t squared, wouldn't it? But I can't do t squared because I need t fourth. So it must be t squared and t squared. Is everyone cool?
Okay.
All right. And then plus 6 plus 6. Are we still okay? Because we knew it was plus and plus. Now what do I got to divide by? 9. And then what do I do with both fractions? Simplify to 2 over 3 and 2 over 3, correct? Yeah. Then where do the denominators go? In the front. So 3t squared plus 2 times 3t squared plus 2. Then we check. Is 3t squared times 3t squared 9t to the 4th? Yep. Is 2 times 2 positive 4? Yep. So we know we're right. Even though it looked different, we just followed the same rules. What if this was t to the 6th? Then what would this be?
T to the 3rd.
T to the 3. What if this was t to the 12th? What would this be? T to the 6th. You picking up what I'm putting down? What if it's t to the 5th? Could you do it? No, because it's not even. Unless you can GCF it to make it even. Everybody with me? Everybody cool? Okay, so 10, 11, 12, 13, and 14, you already know it. I'm going to remind you about 14. How do we do that one? Square root of the first one. What's the square root of y squared?
Y.
Y. Plus square root of the second one? 7. and then we just write it again. Cool? All right, now we're going to do a couple of other special ones just to get you aware. Does this look weird? A little bit. Watch. A equals x minus 7. I showed you this yesterday. So if A is x minus 7, what can I write here instead of A? Instead of x minus 7? A. So that is now A squared minus 81. You know how to do that, don't you? What's the square root of A? What's the square root of this term? A plus 9 and A minus 9, yeah? Everyone still cool? Great. What is A? X minus 7. What's x minus 7 plus 9? X plus 2. X plus 2. And what's x minus 7 minus 9? What's minus 7 minus 9? X minus 16. And it's done. Does everyone see that trick? Okay. Now look at this. What does that look like? Is that a squared minus a squared? Don't we know how to do those? We do, don't we? What's going to be the square root of that? Can you substitute? Can you say that's A and that's B? Right? So that's A squared minus B squared, isn't it? What's the square root of A? Of A squared. It's just A, right? So this must be 2x plus 3, yeah? Because that's the square root.
Yeah.
Plus, what's the square root on this side?
4x.
4x minus 7. And the other one is the same thing. 2x plus 3 minus 4x minus 7. Correct? What's 2 plus 4? 6x. What's 3 minus 7? Negative 4. What's 2 minus 4? Negative 2x. And what's 3 minus minus 7? Positive 4. And now that's done. Does everybody see how it works? Nothing changes, does it? Now look at 18. Does 18 look weird? A little bit weird, doesn't it? So you see this big ugly thing. What are you allowed to make that guy? A letter, right? So watch. If that guy's A squared and that guy's A, then rewrite this. What do I have? A squared plus 8a plus 12. Don't you know how to factor that? Multiply to what? 12 and add to what? 8. What is it? 6 and 2. A plus 6 and A plus 2. But A is not anywhere in this equation, is it? What's A really? 2x plus 7 plus 6. And what's A really? 2x plus 7 plus 2. What's 2x plus 7 plus 6? 2x plus 13. And what's 2x plus 7 plus 2? 2x plus 9. See how easy it is? We're allowed to do this.
Can we review more questions like that?
There's a ton in the textbook. Okay, and we're going to do one right here. So what do I get to do here?
Say it's A.
Say it's A. And then I rewrite. a squared minus 4a minus 45. I know how to deal with that. What do I have to multiply to? Negative 45. What do I have to add to? Negative 4. So it's a plus and a minus, yeah? What is it? This is the only part of this that requires skill, isn't it? Finding the factors.
It's 9.
It's 9 and 5. Which one's positive?
The 9 is positive and 5 is... Oh, no, the 5 is positive.
5 is positive, 9 is negative.
Yeah.
Right?
Yeah.
Now, what's A?
4x.
4x plus 3. So this side is 4x plus 3 plus 5, correct? Agreed? Okay. And what's this side? 4x plus 5 minus 9. What's 3 plus 5? Plus 8. And what's 5 minus 9? 4x minus 4. Everyone see how easy it is? That's it. Simple, right? With the 4 basic ways of factoring, you can factor crazy stuff like this. Next year, they're going to make you factor this. Watch. Everybody look. Y squared plus 7y plus 12 all squared plus 6y squared plus 5y plus 6 plus 8. They would make you factor that. But even that you could do right now, couldn't you? Because you'd factor that, and then you would just start collecting like terms. See how it's nothing different? Everybody cool? Okay. So here's what I want from you guys today. You're going to do page 177. And I want you to finish these notes. We didn't do 7, 8, 10, 11, 12, 13. Oh, and 17. That's your job. It's not a lot, right? And the textbook page is pretty short.
Where's all those new garbage cans in that?
Outside.
That's not helpful. There's 2 directions I can go.
They're both. They're left and right.